we're going to be discussing calibration and performing a basic 1/128th of an acre calibration method. So why is calibration important? You need to have an understanding of what the output of that sprayer is before you apply a product. And this is important from the standpoint of being able to abide by the label directions in putting enough product on per that label, and if there are volume requirements based on the label. Say the label recommends 1 pint of product in a minimum of 10 gallons of solution per acre. You need to understand what the output of your equipment is. Also, without understanding the rate of application, your calibration, which is, it can be expressed as weight, such as pounds or ounces, dry ounces, or volume, such as pints or fluid ounces over a given area. Say 1 pound per 1,000 square feet, or 16 fluid ounces, 1 pint per acre of product. You need to know what the output of your equipment is so that you will know how much area you can cover per tank load, to know how much product you're going to be able to put in per load to cover that many acres or 1,000 square feet. So all of this is important because what you are striving for is ultimately effective pest control, and you don't want to be wasting time and money, say putting on too little product to get that effective pest control. And then you want to do this application in a fashion that is safe for the environment and safe for yourself. So now that we've defined why calibration is important, let's look at the 3 factors that affect calibration: nozzle size, sprayer speed, such as the rate of travel, and pressure. And maybe it goes without saying, but the larger the nozzle size, the greater the flow. If you have drift concerns, using a larger nozzle will produce generally larger droplets, which will minimize drift. That's something that can be of concern in certain areas, certain sites, and depending on what and where you are spraying. The sprayer that we're going to be calibrating today happens to have T-Jet XR 8003 VS nozzles on it. And the important thing to note about these is the XR stands for extended range, meaning that it'll maintain a pattern over a wide pressure range. And the 80 designates that this is an 80-degree nozzle, 80 degrees of pattern from the nozzle tip. And this is a flat fan nozzle that has a tapered pattern with most of the volume of the pattern is in the middle 2/3 of that fan, meaning that you need to have some overlap. About 30% overlap is what you shoot for with these type of nozzles. And the 03 is important to note because at 40 psi, this nozzle will put out 0.3 of a gallon per minute. The blue designates kind of a medium coarse droplet size. That's kind of an industry standard. They've got various colors for nozzles, and the V is T-Jet brand type of color coding, Visicolor, and the S stands for stainless steel. This happens to be a stainless steel nozzle, which is a better grade of nozzle, harder material, doesn't wear as quickly as, say, brass or plastic. This happens to be a T-Jet nozzle, but there's numerous manufacturers out there, so it could be a good idea to visit their websites to get more details, more information about the nozzle options. Remember that if you're going to be making major calibration adjustments, this is the best place to start. Change your nozzle sizes or patterns. Without making other adjustments to, say, your nozzle size or pressure, sprayer speed has an inverse relationship with the rate of application. As an example, if you don't change the flow rate, but double the speed of your sprayer from, say, 4 miles per hour and an application rate of 20 gallons per acre, and then you speed your sprayer up to 8 miles per hour, that would cut your application rate down to 10 gallons per acre. You'll cut your application in half. So unlike speed, which has an inverse relationship to application rate, pressure has a direct relationship. As your pressure increases, your application rate increases. But remember, it takes a fourfold change in pressure to bring about a doubling of your application rate. For example, if you start at 20 pounds per square inch and have a 10 gallon per acre application rate, you'd need to go up to 80 pounds per square inch to get a 20 gallons per acre application rate. Pressure is a good way to make subtle changes in your application rate as compared to major changes where you would want to be changing your nozzles. Here's a chart that shows the effects of changes in nozzle size, pressure, or travel speed on application rate. So now that we've discussed the parameters, let's calibrate the sprayer. Again, we're going to be using the 1/128th method of calibration. And what's significant about 128? Well, you know that's how many ounces are in a gallon, and the industry standard for nozzle spacing is 20 inches or 1.66 feet, and we're going to lay out a test course that is 204 feet long. So 204 feet by 1.66 feet is approximately 340 square feet, which is 1/128th of an acre. So you can make this direct comparison with ounces to gallons per acre. First, you'll need to determine what a comfortable or suitable travel speed is based on your field's conditions. Have your sprayer tank filled approximately half full of water to simulate an average condition. Next, set a pressure for your sprayer. Then, measure out a 204-foot long test course and mark it with flags. Run at your determined speed between the flags and time how long it takes. You will want to have the sprayer functioning as you intend it when you are in the field, with pressure set and all booms on. Having an assistant for this part can make it easier and more accurate. Consistency of speed is important here. Do this timing several times and determine what the average time is. So now that we've made several timed passes across our 204-foot course, we averaged those times and came up with 29.74 seconds. So with the machine stationary and operating at the same pressure as during the test, we will hold our utensil under a nozzle to determine gallons per acre. Then we will check several other nozzles up and down the boom to make sure that they're within 10% of each other. We happen to be using these Jiffy jars, but there's other brands of utensils that use this 1/128th of an acre calibration methodology. And they're handy. This has got gallons per acre on one side and row width or nozzle spacing in inches across the other side. We're doing broadcast calibration here, so we're just concerned about the nozzle spacing. But you hold this under the nozzle for that elapsed time at that consistent pressure again, and read where the water level comes up to, and it tells you gallons per acre. And it probably goes without saying, but you want to be using just clean water when you're doing these calibration methods. I happen to have rubber gloves on just in case there's some residue in the tank yet.
3, 2, 1, stop. Okay, and we're at 21.5 gallons per acre. You go to your 20-inch spacing. Actually, closer to 22, yeah, 22.
So now that we've calibrated, make sure to remember that if you change your equipment, nozzle size, travel speed, pressure, you will need to calibrate again. The most important thing to remember about pesticide safety for the sake of the environment and your personal health is to read, understand, and follow the pesticide label. If in doubt, ask questions of your sprayer manufacturer, your chemical company, or your extension agent. So happy calibrated spraying.